Question number 19 on the worksheet on forces on inclined plane. A block of mass 12 kg is placed on a plane which is inclined at an angle of 24 degree to the horizontal. Okay, if it's a 12 kg mass, that would mean a component of weight in this direction, which would be mg cos theta, and a component of weight in this direction, which would be mg sine theta, and a normal contact force in this direction. Okay. A light string making an angle of 36 degree above the line of greatest slope is attached to the block. The tension in the string is 65 newtons. Okay, now the 65 newtons need to be resolved into its horizontal and vertical component as well. The one that is between the two angles, 36 degree and 90 angle, is the adjacent component, which is the cos component. So this one is going to be 65 cos 36, and the one that is opposite to the angle is always the sine component, and instead of making the sine component here, I'm going to point it here upwards. So this is going to be 65 sine 36. Okay. All right. The coefficient of friction between the block and the plane is mu. The block is in limiting equilibrium, that means it's not moving yet, and is on the point of sliding up the plane. So that's very clear. If it's going up the plane, the friction has to be down the plane, mu r. Okay, find mu. So it's in equilibrium, that means this force is going to be equals to these two forces. Let's write down the equation. 65 cos 36 should be equals to 120 sine 24 plus mu r. And r, for r, you have to equate these two forces. Up forces is equals to down force. So to find r, we're going to do r plus 65 sine 36 equals 120 cos 24. So r will be equals to 120 cos 24 minus 65 sine 36. I'm going to substitute that here. So I'm going to do 60 cos 36, bring the 120 term to the other side, subtract, is equals to mu times, replace r with all of this, 120 cos 24 minus 65 sine 36, and then divide this bracket term here in the denominator, bring it to the denominator, and this should get you the value of mu, which comes out to be, let me just double check the working. Looks good. Okay, mu comes out to be 0.0529.